back, everybody. We're into the final straits, and it's my great pleasure to introduce an American computer scientist who is lauded as one of the founding fathers of the internet and has won a host of awards and been recognized globally. Things like the National Medal of Technology, the Presidential Medal of Freedom, and he's now Google's chief internet evangelist, Mr. Vint Cerf. So please, warm welcome to Vint.
So actually, first of all, I'm your dinosaur entertainment for the evening. I don't know whether you heard about the dog that talks. Some guy found a dog that can talk, and he takes it around to various auditoriums, and everybody's very excited. It doesn't matter what the dog says. The fact that the dog can talk is what's so amazing. So I'm your talking dinosaur for the afternoon. I have to tell you that I wish that I could have been here for the earlier events, because the one I just watched, the last two, were just wonderful. They were funny, they were informative, they were concrete in many ways, but I had to be downtown arm wrestling with some of our friends in the French government. So in a good way, it was all positive exchanges. One thing that I did want to ask about, though, is whether these kinds of events this is the second time we've done this, is that right? So one thing I'm very interested in, just as an engineer, is to know whether we have evidence that the feedback that comes from talking to you face to face and listening to some of the experiences is having a direct impact on the way in which our products evolve. It's very important from my point of view to have that kind of feedback, especially from people who are trying to use the systems, talking to the engineers who are trying to build them, and the product people who are trying to design them. So one thing I hope we do with these events and others like it is to measure ourselves at Google about how well we're able to respond to the inputs that we get. I had not intended to have a big, long, presentation and then some Q&A. What I want is lots of Q&A. But I do want to suggest a couple of things to you. In the world of the cloud, there's more going on here than just the ability to dynamically allocate capacity, to replicate information for reliability and the like. The cloud is doing something else which I'm finding quite fascinating. It's taking the media that had been distinct before. We delivered video one way, we delivered text a different way, we delivered audio a different way, sometimes on different networks or on physically different media like paper. And the cloud is allowing us to mix those things together. You see it in the form of mashups, but you also are beginning to see it in the form of complex digital objects that partake of all the various media. This is not just the old multimedia thing where you had slides and audio and maybe some person, a performer or something. This is much more intimate. And what I think we are I am not ready anyway to, not been able to figure out, is what to do with the extremely complex objects that we are creating in software. So when you're using Google Docs, you're creating fairly complex digital objects. And when you're using other applications, not necessarily Google's, you are doing the same thing. The question is, how long will the bits of those digital objects be meaningful? Now, the most embarrassing moment in my career came in a library when I came trooping in with my DVDs and my CDs, and I'm very proud of all this digital stuff. And the librarian listens for a little while and excuses herself, and she goes out into the stacks. And she comes back with a 1,000-year-old vellum manuscript. And she puts it on the table and opens it up, and it's illuminated and beautiful, and if you can still read Latin, you can see exactly what was said. And then she looks at me and says, holding up one of the DVDs, just how long do you think this is going to last? And how long will you have something that can read it? Well, even if the bits are there, maybe the device won't read it. And even if the device is there to read the bits, will you have the software that will know how to interpret it? And of course, I felt like I was about 2 inches tall and wandered off. So one of the things that the cloud may be able to do for us that it would be harder to do any other way is to retain a persistent implementation of applications over a long period of time. And perhaps there are intellectual property issues that are wrapped up in this. When someone announces, I'm not going to support this particular application anymore, if that happened to be in your laptop or your desktop or your mobile sitting on a particular operating system, it's hard for you to retain the functionality. I mean, if the little device you had it on dies, then what? If the new operating system doesn't run the old code, then what? So you have to somehow figure out how we would get permission, not just Google, in the general sense, how do we get permission to take applications that have been declared defunct and keep them in an available form so that they can be used to read and process old data. Some people will say, well, you can always translate the data into a new form and a new application, but I think that's not necessarily always true. So that's what I call the bit rot problem. And I think cloud environments may actually help us overcome that potential risk. So I'm going to, I don't want to say anything more in this lecture-like format. What I really want to do is to find out what questions you would like to have me or perhaps others at Google respond to. So if there is, there's already a question here, and if we get microphones. Now, one thing I need to warn you is I'm hearing impaired, and I hate to be the guy that came to talk and didn't listen. So it doesn't mean you should shout. What it means is that if the audio on the stage is crappy compared to the audio sitting out there, I may dash off the stage to lip read you or something. So don't be afraid. I'm not running down to go bite or spit or anything else. Go.
Okay, I kind of became a convert to cloud strategies a couple of years ago. It was actually at a Google conference that I heard something about the consumerization of IT and when compared to corporate IT, that sort of stuff. And what I've learned over the last couple of years, it's great, and I'm there mentally. But one of the big worries I have is this, and that is when I look at the company I work for today, over the last 20 years or so, we've built up an inventory of massive fragmentation across our business applications. Lots of them. It's not just that they're old. Even old things can be very valuable.
God, I'm glad to hear you say that.
I set you up for that one, so you won't. I guess what I'm trying to say is, 20 years ago with network PCs and client-server computing, that put the power of computer technologies in the hands of the departments, and they all rushed off and did their own thing. And I can remember as a young executive reading a Gartner report that the matching up islands of information was the biggest concern of IT directors at that time. I'm pretty sure that if there was an equivalent Gartner report, it would be the same thing today. Now, when you look at cloud technologies, it kind of accelerates that, doesn't it, a bit? It puts these technologies in the hands, even more so. It's cheaper and they can be deployed quicker. I think that will be borne out in the coming few years. It kind of means that maybe in 10 years' time, instead of having masses of fragmented proprietary architectures, we've got IT departments who are finding it difficult to manage hundreds of fragmented cloud solutions all bolted together in some poorly defined way. So how do we prevent that?
Okay, so I don't know whether we can prevent it, but we can take some steps to try to circumvent that problem. Google has made a commitment, I think we sort of call it data liberation, but the basic notion is if you put information into our cloud, you should be able to get it out. But then there's this other problem. There are different kinds of clouds, and they have different kinds of functionality and capability. So either it's Amazon or Microsoft or IBM makes private clouds and things of that sort. So I've been thinking a lot about the problem of getting clouds to interact with each other. Even if the only trivial notion was simply to get the data out of this cloud and put it over into this one. If you will let me take you back to 1973 for just a moment, we had a very similar situation in the networking game. We had proprietary network technology, SNA from IBM, TechNet from Digital, DS from HP and others. The problem was that none of them interacted with each other, and the vendors liked that because if you needed to have a network system, you could lock your customer into HP equipment or IBM equipment because they can only talk to themselves using these proprietary networks. So when Bob Kahn and I started working on the internet design, we wanted it to be non-proprietary because we didn't want the Defense Department to be locked up having to use only one vendor's equipment and networking capabilities. So we developed this non-proprietary thing. Well, the ARPANET program, which was an experiment in packet switching, which began around 1969, had a problem kind of like that. We had different computers with different operating systems and different kinds of terminals. And as we were trying to build this uniform ARPANET thing with these heterogeneous operating systems, one of the problems was how do I get a terminal on this computer to communicate to an operating system, a time-sharing system, across the network that was different? Well, the terminals of the day were all very different, and so the drivers for them were specific to each operating system. So imagine you've got quite a wide range of different terminals connected to these different hosts, different operating systems, and you're trying to figure out how to get this remote host to properly interact with every possible kind of terminal out there on the ARPANET. We said that's impossible, that's an n-squared problem. So we said, why don't we invent something called the network virtual terminal? It didn't exist. It wasn't real, but it was a convention, and we said that any host on the ARPANET, the predecessor to the internet, any host on the ARPANET, when it received a terminal-based interaction, had to receive it in this network virtual terminal form. And that network virtual terminal was what all the hosts knew how to service, plus whatever ones they were physically directly connected to. I think we need a network virtual cloud notion. Now, this doesn't mean that the convention for a cloud in this network virtual cloud necessarily can reflect every functionality that every cloud can do, but it does have to reflect functionality that all clouds might be willing to provide. So at the minimum, you have to be able to say, take this data from cloud A and put it in cloud B. Of course, your job is not quite done. Let's suppose that in cloud A, that data is protected. So there's access controls in cloud A. There's metadata to implement that access control. We also need to make sure that this network virtual cloud idea can take the metadata and have it interpreted in cloud B in such a way that it performs the same access control that it did in cloud A. Now, if you start digging down into this, you can find all kinds of trailers off into the jungle. But this notion of trying to establish conventions that will allow cloud operators to interwork with each other seems to me absolutely essential to avoiding the problem of being locked into a particular cloud, which I don't think is a good thing for anybody. So that process is underway. There are a number of different organizations looking at different ways of linking clouds to each other. Of course, we could get very ambitious at some point. We might say, well, it's not just the data that I want to move. I want to start a process in this cloud, and I want a process in that cloud, and I want them to interact with each other in real time. Maybe this cloud has features that that one doesn't, and I want to take advantage of that, but I still need to exchange information, possibly in real time. So I don't want to go on and on about this, but I believe that if anybody's looking for a really good dissertation topic, the definition of network virtual cloud and how it would work would be absolutely cool, super. We have to do it, and I believe it's quite doable. This is no worse in some sense than inventing the internet. And that wasn't as hard as it sounded, so, or you might think. So it's its implementation and its expansion and evolution that was hard, and the scaling, of course, is pretty tricky. So let me stop there, because otherwise I'll be like a Stanford professor with a trapped audience. What other questions have we got? I used to be a Stanford professor, so we love it when we can close the doors and you can't leave without signing a contract. That's what, oh, I wasn't supposed to say that, was I, Dave? I'm sorry. Okay, who else has a question? And if you don't mind waving your hand, yes, over here. Thank you. Yes, sir.
Yeah, hi, my name's Chris Evans.
Hi, Chris.
We heard some phenomenal statistics this morning about 300 billion emails and zettabytes that I've never heard of. Where do you see this going in 10, 20 years' time? And who decides to delete it?
So let's see. First of all, the scaling curves have never let up. Let me do a little piece of math for you. In 1979, I bought a 10 megabyte disk drive that was the size of a shoebox for $1,000 US. And then not too long ago, I bought 2 terabytes of the disk drive for about $200. And every time I say that, somebody says, I got mine for $150 and you went to the wrong store. But, okay. So I thought, what this is interesting. What if I tried to buy a terabyte of disk storage in 1979 at the then prices? If you do the math, I think it comes out to be $100 million. I didn't have $100 million in 1979, and if I did, my wife would probably want me to spend it on something other than disk drive. I am hearing about technologies that will take us well beyond the current densities of storage. So storage density, I'm not worried about. Molecular level storage is sure to come. One of the problems, however, is getting something out of something that has, exabytes of memory in a cubic, meter or a cubic centimeter. So data rate is part of the issue. I believe that we are going to have to shift to different kinds of paradigms for processing of information. I want you to think for a minute. Did we show anyone earlier today what a Google data center looks like inside? Okay. So I know it's all top secret classified, but let me imagine that for a moment. Think about racks of things, just endless racks of things, sucking power like crazy and radiating heat. I tried to get people to put pizza ovens at the top as a second line of business, but they said the cheese would drop down into the circuit boards and make a mess. So we didn't do that. What you're seeing, though, if you step far enough back from a data center, the architecture of that data center is processing embedded with memory. That's really what's going on. Every single board has processing power and a whole bunch of memory. And it's all stacked up like this and then replicated. Parallelism is the only way we are ever going to get the scaling to work right. Otherwise, it's just like having a processor that's running, like a little gerbil, high speed, and it can't get all the data in and out of the memory that it has available. So I predict that the scaling of computing and memory is going to require increasing amounts of parallelism, which is precisely what you see in today's data centers. It may be implemented in smaller and smaller packages because the physics may allow us to do that. But if you think a little bit about the 2 or 3 pounds of gel in your head that is capable of doing so much in such a short amount of time but operating very slowly, it's only because it's got 10 to the 14 things going on in parallel. So that's where I think we're going to end up, lots and lots of parallelism in this equation, and higher and higher data rates linking these various systems to each other. Okay, other questions? Way in the back there, and then there are other hands, but I'm assuming the folks with the microphones figured that out. Yes, sir?
My question is regarding trusting the cloud with our data. It sounds to me like trusting the bank with your money rather than having it in your safe box at home. Trusting the cloud rather than having your data within your firewall. But the difference is that if my money gets leaked out of the bank, I can tell from my balance. What if there's a leak of information from authorized employees by the cloud? I'm not talking about hacking, because I'm sure they have better experts than ours, but about authorized employee who has access to this data. How can we tell?
So actually, it's a very reasonable question, and if you're following any of the news stories, you'll know that Google has a lot of rules about who has access to what information. After the reported problems that we had in December and January this year, we went through a very significant and in-depth evaluation of our system and its access controls. We instituted quite a wide range of internal access controls to limit the people inside of Google who have access to various parts of the system. So if you were worried about internal access and the potential leak that way, we made a number of very deliberate steps to shut down the range of people who have significant access to internal databases. We also recognize, we don't need any more motivation. We know absolutely that no one will be interested in a system that they can't trust. So we understand that implicitly. The mechanisms that are built in to the data centers and the data structures and the underlying infrastructure, software infrastructure, are organized around access control. That's why you can't get Google Docs without having a Gmail account so that we can identify the party that is trying to get access to a Google Doc. That's why you can say which Gmail accounts are permitted to have access to and what kind of access they have. It's fair to say, well, what if the software doesn't work right? And I freely admit that not all software works 100% of the time, so there's always some risk factor there. One thing I will say, just on my own behalf, not necessarily on Google's behalf, is that I am intensely interested in improving authorization mechanisms. So we've adopted one-time passwords with a physical device in order to identify our own employees and what access they have. We can't build a VPN connection without one of these physical one-time password devices. I would love to see that someday be available to all the users of our services as well, to the extent that they want that kind of strong authentication. So those are all mechanisms that are part of the solution to the problem. And you said you did want to talk particularly about hacking, but I think we should talk about that. That's always a potential hazard anytime you put something on the net. You know, the expression is, the good thing about the internet is everything is connected, and the bad thing about the internet is everything is connected. So we do a lot of work to try to isolate our systems from external attacks, but we also have recognized that you have to do the same thing inside, because it's always possible that something could get inside around the firewalls and around all the other protection, you know, a memory stick with a virus or something. So that means that you have to build machines that are resistant even inside the data center to various kinds of infiltration. So those are the steps that we take. It can't be guaranteed 100%, but you can be sure that we are extremely aware of how important that is, and we have smart people who work on it. Okay. Next question is somewhere. Do you want to pick? I'll shut up and wait for a hand to wave. How's that? Over here, and then over here is next. Okay. You were before him. Okay. Let's you and him fight. No, I'm sorry. Go ahead. You're the gentleman in the front.
Okay. Good afternoon, Vint. My name is Peter Morbius from Switzerland, and I would like to actually see a bit what you think about the different worlds of fixed network and mobile networks. I mean, if I see all this data evolution, I think you would obviously wish that the mobile world follows exactly the fixed net world, that also this boundless bandwidth is available on the mobile network. Can you see that this is actually happening? Because I can't help the thought that there's a limitation on bandwidth, on spectrum, etc. What are your thoughts on those three axes?
Two things. First of all, the architecture of the internet was not very well designed for the kind of mobility that we're experiencing. The first mobile network we had was packet radio in the mid-1970s, and basically we assigned an internet address to a device, and the network followed it around, so we didn't have to change the IP address. And I thought, okay, we're done. We have mobility, you know, what else is new? Now, what's happened is that we didn't anticipate that these little devices would be, instead of being driven around in tanks, would be carried in people's pockets, and that they would find it necessary to change their IP addresses because their access point went from one IP network to another. So that was actually something I had not adequately anticipated. Technologically, we should, in fact, make some changes to the protocol space in order to accommodate that. And without going into all the detail, because I only have a few minutes left, I can tell you that if we solve the problem of dynamically changing IP addresses, that we will solve the problem of multi-homing, we will solve a number of other problems that are in the way of making things very resilient. So that's still to be done in the future. There is work going on in the Internet Engineering Task Force right now to standardize, like HIP is an example, to standardize ways of allowing mobility in the way that we experience it now with mobiles. In terms of bandwidth, there is an issue. There is an unlimited amount of bandwidth in the radio spectrum. That's a physics statement. The problem is that the different wavelengths have different propagation characteristics. So that's why we were so excited when we pushed into the white spaces for television, unused by television, because those frequencies are low enough to have very good penetration characteristics, and they would allow propagation over longer distances than you get even with 802.11 and 2.5 2.4 gigahertz. So I think that we can't have as much available bandwidth in the radio spectrum as we can get with fiber. On the other hand, if we are willing to accept relatively short distance communication, we can have a very significant amount of local bandwidth because of the reuse of the spectrum. So if we keep power low, we can probably get a very big gigabit level bandwidth, even with radio-based spectrum. I'm very interested in two things. One is the reuse of spectrum that, as in the white spaces, and the other one is experiments with cohabiting in an already existing spectrum. Today we have technologies, I don't mean Google specifically, but generally available technologies that will allow multiple devices to share spectrum at the same time without very much interference. Whether it's CDMA, for example, or the various forms of frequency hopping, various forms of orthogonal coding systems, we could cohabit in spectrum better than we ever could before because we didn't have the technology to do that. What I find very exciting is that if you're willing to pursue that, then you can take larger chunks of spectrum, giving you much higher bandwidths, just like you do when you get an optical fiber in a whole wavelength, and allow the cohabitation and tools for keeping people separate to give you much, much faster speeds, even in the wireless environment. So I have been encouraging our FCC in the United States, and I certainly would say the same thing to others, to experiment more fully with this sharing of spectrum tactics and more broadband availability in the wireless world. Now we do have a gentleman back here. Yes, sir.
Yes. Well, my name is Jorge Martin from Spain. Going back to data, and especially on the librarian that took that went to find the 1,000-year-old book.
Yeah.
Sometimes it's important to know the exact location, talking about physical location of the data, especially when you're talking about regulations by governments, and etc. So this is kind of not very compatible with the cloud. So I would like to know what steps or what are your predictions on making this more compatible?
So this presumes, of course, that I agree that we should worry about where the data is. And I will confess to you that when we designed the internet IP address space, the first thing we rejected was the idea of allocating the IP address space by nation. You remember this was being built for the Defense Department. We figured it didn't matter where the equipment was, you know, you were wherever the theater of operation was, it didn't matter which country so much. What did matter was connectivity, topology, and so we designed it all around connectivity. Well, once the net became commercially popular, it exists in the real world. Your points are quite well taken. Some jurisdictions care about where data goes, and in Europe especially, the concept of transborder data flow has been part of the vocabulary since the OECD reports in the 1980s. So I wonder, I have two responses to this. One of them is I wonder whether we should try to rethink the utility of trying to control data crossing borders. It may be that that's not the problem. The problem is, what did it cross the border to land in? And are the characteristics of the place it landed in satisfactory or not? You're familiar, I know, with safe harbor notions and things of that kind. If it turns out that we can establish safe harbor practices, then clouds that can meet those requirements might not be as much of a concern with regard to their physical location as much as it is their functionality. The other thing I would observe about at least the Google Cloud, about which I know more than the others, even though that may not be very much either, is that we work very hard to replicate data in a number of different data centers on the belief that a massive failure of some kind will not necessarily cause the data to be inaccessible to you, whether it's your documents or your email or your other applications. So I would much rather work, I think, on finding ways to make the distribution of the data more acceptable to the jurisdictions that are worried about that than I would be to try to isolate things and say, well, don't put my data in country X or don't put my data in country Y. So we do know, however, where IP addresses are, how they're associated with countries, although that's not 100% perfect. So we could conceivably try to deal with that but I much prefer this alternative approach. I think I saw a hand over here. Yes, sir.
Thank you, Mr. Cerf. I'm Javier Sanchez from Recall Networks, Spanish Google partner. I'd like to ask you for a forecast on IT workforce. During the 90s, the popularity of the IT produced that the universities issue a lot of IT professionals that were very demanded by the companies. Now that all the IT work and development, the good IT work, is being concentrated back to companies like Google and others, to the cloud, and that the companies are going to break the demand on the IT workers, what will happen in the next years? The universities will stop producing IT professionals. Maybe there will be a shortage of IT professionals in the future?
It's a very good question, and this has come up, by the way, in several different instances just in the last few weeks. Some companies are actually going to the trouble of creating training centers in order to train people to deal with problems that they need to have solved that they might not have learned in the ordinary curriculum. Think of Cisco and Microsoft and others with their certified engineering programs. Alan, wherever you are, we might actually consider the possibility of having certified, Google Apps engineers or something like that. I think two things can happen. One, companies that need to train people for their requirements will be forced to do so if they can't get any other method. But we should be, and others should be feeding back into the curriculum of the universities things that we believe are needed. I'd point out one other thing. Every time you finish a program, whether it's a 2-week certification program or a 4-year program, degree program, the value of what you learn begins to degrade immediately. And eventually you know more and more about less and less until you practically know everything about nothing or something like that. So, or maybe you know nothing about everything. So we need to recognize as professionals that continued training is absolutely essential. The one thing that makes me very hopeful about this is that the net itself may turn out to be the kernel of the solution to the problem. When MIT put all of its information up on the net, the other university said, "You're crazy." And the MIT guy says, "No, it works it's just this way. People see our material on the net. Either they understand it already, in which case they don't have to come to MIT, or if they don't understand it, the only place they're going to learn it is to come to MIT. And that's sort of working. It's also doing something else. And this is where I think the synergy is really exciting. If the universities and the companies are willing to share training information, and it's accessible broadly on the net, which is what Google is all about, trying to make the world's information accessible and useful, then teachers may be able to draw on information from a variety of sources and help train people more fully and more completely. Some of my colleagues are doing this now, not at Google, but in other fields, in medicine in particular. They're producing presentations online and they're making them freely available. Nobel Prize winners are doing this, and it's kind of a grassroots process. Eventually, maybe a lot of the important information for training and learning will be online rather than locked up in traditional textbooks. So if you care about that, I hope that you will personally push to get that information out there. It says 0 there, so I'll do whatever the moderator wants me to do here. It could disappear, or take one more question at least. Should we do that? There's where's over here? Yes, sir.
My name is Matthew, and I'm from Nairobi, Kenya. If you look at it right now, what Google is doing is like a recycling of technology. When we started with mainframes, and everybody would connect to a system in the back end. So there's a trend that after a number of years, technology is recycled. Even beginning from initially when disks used to have contiguous information storage, and then they changed to read rates and everything. Then all of a sudden, again, when you come with a disk, it became contiguous information. So, what do you think will happen? Do you think we'll ever come back to the point where everybody will have their own processing capabilities in their own behind their firewalls? Or
So,
where do you see it going? I'm not asking you to predict. I'm just saying, where do you see this going? Where do you think it will end again and change over again?
So I love these questions because they're the ones that I can demonstrate I don't know how to answer very well. Because I didn't know, for example, that 32 bits was the wrong number for the address space in the internet. And now we're running out, and we have to do IPv6. By the way, if you take nothing else from my part, go get IPv6 implemented throughout your system because you're going to need it. And it's not super hard, but it's also non-trivial because it's like the Y2K problem. You have to find every place in the code where it thinks an IP address is 32 bits and make sure it knows it should be 128. And sorry, I just couldn't resist that. So, honestly, I think we're going to continue to see people carrying increasing amounts of computing capacity and memory and everything else around with them. We're going to see more things on the network, just appliances that you have at home or at work or in the car that you carry with you. And still, it won't be enough for you because you're still going to wind up having to process this increasing flood of information that's becoming available. And Google's even contributing to that with the Google Books program, and every one of us and our friends is contributing to that by uploading more and more information into this common environment. So it's not possible to get access to all that information, no matter how much computing power you have in your house or in your pocket. You have to have the help of the data center style systems, and frankly they have to be distributed in order to hold and process all that information. So I think that the cloud-like environment is almost an inescapable consequence of the amount of digital information that we're producing. I guess the statistics you heard earlier, that whatever is 24 hours of video being uploaded per minute into YouTube, just imagine all the other digital objects that may eventually find their way into common representation in the World Wide Web. So whether we like it or not, our lives are going to be embedded in digital information, and we're going to need a lot of help to process that. It's nothing new. You don't read every newspaper and every magazine or see every movie or watch every television show. You rely on hints, recommendations from your friends, trademark publications that you trust have good advice for you. So that trend is simply continuing in the digital environment, and we need a lot of processing power to make that happen. That's all the time that we have, but thank you so much for letting me join you, and I'm going to look forward to the next part of our program.